We're going to now look at a second method of doing this polynomial division called synthetic division. It's sort of a shortcut of long division that works in certain cases. So you'll see I have written here, if the denominator or the bottom is strictly of this form x minus a, then we can use synthetic division. So it only works in this situation or if we can force this situation. So I've given an example here, q of x equals, and we've got this cubic 9x cubed minus 6x plus 1 on the top and x plus 4 on the bottom. So maybe it doesn't look like that's of the form x minus a, but that's a really easy fix. Because instead of adding by 4, you could do equals x minus negative 4, right? So those are the same thing. And so what that means for us is that our a value would be negative 4 to make this work. That would give it in the correct form that we're looking for. So what we're going to do with synthetic division is set up this, this sort of L here. And what we'll do is write the a value on the left side. And then what we're going to do is list the coefficients of the powers of x. And you do want to be really mindful. It should go in this sort of descending order. So we should have the x cubed. And then, so if x cubed, or if 3 is your degree, then you need every power less than that. So I need an x squared, an x, and then x0 or the constant. I'll usually just write a 1 for that. And so that tells you what your columns are going to mean. You don't have to write that at the top. I just find it's not doesn't take a lot of time, and it will really organize my thoughts for me. So I'm going to write that, and then what we're going to write underneath each one is the coefficient of those powers of x. So it's 9x cubed. There's no x squared, so I'm going to write a 0. There's negative 6x, and then 1 of the constant. So what you're kind of doing here is sorting out what you would have written to start long division, but without writing the powers of x. And so if you remember in my lesson on the long division, I really strongly suggested to keep your columns lined up because it makes all the arithmetic really easy. So what synthetic division is going to do for you is it's going to assume that where you place things in the column, that you've done it according to the right powers of x, so that you don't have to keep writing those powers of x because it's really repetitive. And it just sort of does that in the action itself. So we start off like this. And there's going to be basically 3 steps. So what we'll have here is step 1. So what you'll do is add up the column. So I should make a note. What you're going to do is start at the leftmost column. In the L. And we're going to add up the column. And I mean, in this case, there's only a 9 in the column. So adding up 9 with nothing else is going to give you a 9. So maybe I'll just write a little equals here. Step 2 is going to be multiply that sum by your a value. And so in this case, the a was minus 4. So we're going to multiply it by 9. That's a times, not an x. And when we multiply those, we should get negative 36. And so then we write that in the next column. And finally, what we're going to do is move over to the next column. So we're now in the second column. And then return to step 1. Yeah, so now we're in the second column. What we're going to do is add these two things together. I think I chose some wacky numbers and they might start to get pretty big, but that's okay. So I'm going to add the two things together and I'm going to get negative 36. And then now I'm at step 2, so I'm going to multiply my negative 4, by negative 36. Ooh, that should be, well, it'll be 72 times 2, so 144. And positive because they're both negative. I don't like where this is going. Yeah, then we'll add the two together. 144 minus 6 will be 138. Oh, now I'm going to have to show off my multiplication skills because I don't have a calculator handy. So the last one is going to be multiplying the negative 4 by 138. What should I get? 400, 120, and then 32. Let's go with that. So that should be 552 and negative. And yeah, so I'll add those together. I will be willing to admit if I've made a mistake here. Please call me out, and I'll probably have to like redo the whole video. But hopefully you get the idea, even if I did make a mistake. I'm not going to check my answer for that reason. Yeah, so we add it up. I get negative 551. And so what we've got is this line of numbers across the bottom. So the question is, what do these numbers mean? Well, they're very nicely organized. And what we're going to get is kind of a shift of the labeling above. So this last number is actually going to be your remainder. And then the second last one is your constant. And then you make your way up powers of x. So the next one will be x, and the next one will be x squared. And now we put this together very similar to how we would have done this with long division. So this pile of numbers here, the leftmost ones, all are going to come out of the division cleanly. And so what we'll get is q of x equals, and so the first one is 9x squared minus 36x plus 138. And then the last chunk on the right is your remainder. So it's going to stay inside the fraction. So minus 551 over x plus 4. I regret my choice, but it gives you numbers and you can see what's happening with the numbers. So I apologize if there is an arithmetic mistake in there. I didn't think to grab a calculator, but hopefully you can at least sort of follow along with what's going on. It's basically add the column, multiply, add the column, multiply, add the column, multiply, stop, and then put it all back together. So I'm going to give a couple more examples. Okay, so I've written down a second example. In this case, what we've got is 9x squared minus 6x plus 4 along the top, and then 3x minus 1 along the bottom. So this 3x minus 1, again, it's not quite in the format that we want for our denominator. We want this x minus a. But what we do have is that our denominator 3x minus 1 is linear, right? It's of the form mx plus b, which x minus a is. And if it's linear, that means that we can fix it. So what we can do to fix it is actually just divide out the 3. Or whatever the coefficient out front of x is, because that's the thing that is making this not quite match up. So we need to get rid of it. So what we can do for our f of x is basically, since I know that I've got to divide the bottom by 3, we're going to divide both the top and the bottom by 3, right? Because you can't just divide part of it by 3. In this way, we're essentially multiplying by 1. It doesn't do anything to the expression. And so if I simplify that, what I'll get is 3x squared minus 2x plus 4 over 3 by distributing that division by 3 across the top. And then x minus a third by distributing across the bottom. And so what we're going to have now is that my a is 1/3 to make it fit into that x minus a notation. So same as before, I'm just going to set up my synthetic division. So I have that 1/3 for my a, and in this case, across the top, my highest power is 2, so I'll just have an x2, an x, and a constant. And I'm going to write my coefficients, 9, -6, and oh, no, sorry, that is incorrect. I'm not looking in the right place. And that's something else that should be pointed out. I have to use the ones that go with the expression I'm actually working with. So 3, -2, and 4/3. So maybe highlight that. We're going to use the new coefficients. Right, because that a equals 1/3 goes with the way that I've written that new expression. So yeah, so watch out for that. I almost made a really big mistake. Hopefully don't do what I almost just did there. And now I'm not going to write out all the little notes for synthetic division now. I'm just going to add, multiply, add, multiply, add, multiply. So add the first column, 3, multiply, so 3 by 1/3 should be 1. I'm going to add, -2 plus 1 is -1. 1/3 times -1 is -1/3. And then add, that should be 3/3, which is 1. And again, I'm going to relabel what the bottom represents. So I have my remainder, my constant, and then my x. Because of that shift, you should always see that the power along the bottom is exactly 1 less than the power on the top. And that should make sense because we're dividing by like x in a bit. So that's going to reduce the power by 1. And so I'm going to put this together. My f of x is going to be 3x minus 1, then plus, right, so that 3x minus 1 is coming from here, plus, that drew that a little too long. The remainder 1 is going to give me 1 over, and then that x minus 1/3. So again, remember that does have to come from the new expression. So that's not the denominator that you started with. It's going to be the new one. And if you want to clean that up a little bit, you shouldn't have to, but if you want to clean it up, what we can do is now just multiply the top and the bottom by 3. And that should get rid of that ugly third denominator that we've got. And that's just that rational part, right? It's only touching the top and bottom of that thing. So I'd have 3x minus 1 plus, and then what we would have is 3x minus 1. And you could probably actually check, if I do the math in my head, it looks like it works out. So this, yeah, this seems to give us exactly what we're looking for. We'll do one last really quick example, and then that should be the lesson on synthetic division. Okay, so I've given one last example here. I've got 7x to the 4 plus 3x minus 5 divided by 2x squared plus x minus 7. And the question specifically says to simplify this using synthetic division. And if you're paying attention to that note on the top, the answer to this should be no. The denominator it's not only not of the form x minus a, but it cannot be written in that form. So this denominator, this is a quadratic. The degree of this polynomial is too big. Right? A linear function is a degree 1 polynomial. So anything higher than that, you won't be able to write it as x minus a. So if you were given something like this and asked to simplify, basically the moral of the story is you would have to use long division. because long division always works. But I'm not going to go through that one with long division, but that's how you would have to complete this one. So you could try it on your own, see what happens. But yeah, that's the gist with synthetic division. It works in limited circumstances, but it's pretty fast when it works. So that's the advantage to knowing it. But if you don't want to know two methods, then only learn long division.